please?
No, everyone.
You have got the Google Drive link?
Yes. All the WhatsApp.
You need, before you talk to instructor, you need to talk to each other first. If some of them are getting it and you're not getting it, you need to figure out that there's something I cannot do anything about it. Even if I'm involved in the technical things in here. And I think it depends also on the registration. What I heard, there are students who have not registered yet, they are not sharing anything with them.
Yes.
Huh? Then I need to talk to Dr. Letty or Fasi about it. Unfortunately, technically I cannot help for anything because I don't know how things work. I can help with the lectures. What about the lab reports? Have you worked on the lab report one?
Yes.
Everybody?
Yeah, no.
Did you? What did I know? What did I know? And did you bring the lab report?
Yes.
How many of you did not bring it? Why?
Server
How can you do this course now? It's a hands-on experience workshop course. Right? So server doesn't work, I don't understand. Server here at the iccbs?
हम एलईजी में करके आए थे हम एलईजी में भी बैठ के करके आए थे
But how about these guys? How many of you have done it? How did you do it? The server was working for you guys?
Yes.
So where did you work? Here at LG, at your home, or where? At hostel.
National Guest House and library.
National Guest House? And I think the boys hostel, like, it's working for boys. Right? So I have no idea how to handle that server thing. And you have to have lab report done, otherwise what's the point of this course? Nothing. Right? So I'm just giving you instruction and you're just watching it. Unless you practice everything I'm telling you, you're not going to learn anything. Right? And down to 3 classes, today is the second one. You have to complete your lab reports timely. If you're not completing it, then how can you understand the second exercise or whatever I'm teaching you next? Does it make sense?
Yes.
I have no idea how to fix your server issue. How you think that it can be fixed?
मैम उन्होंने लेट भेजा था रात में अगर कल शाम तक हमें मिल जाता हम उस पर काम करते कुछ भी करते लेकिन उन्होंने इतनी लेट भेजा
What they sent me?
No, they said
Google Drive link? Yes. But I remember the first he immediately shared with me. So at what time? But how come they were at what you managed?
मैम ये लोग लड़के रात 1 बजे तक काम किए पूछा हमसे
So you should have also done this role of work, guys. This is how you learn. This is the sacrifice that you have to pay for learning. You know how I did my PhD? You want to know about it? I don't know whether this is the same situation right now or not. You know the university point that we used to take from my home to the university. My senior colleague who actually trained me how to get into the university point, she said me, Zareen, if you find room for putting a toe of your one of your feet, if you can put your toe on the gate, just get in there and hold the handle. And every day when we used to get into the university point, we used to say kalima. Because we were not sure whether we will be coming home alive or not. Whether we will be reaching to the university alive or not. We have seen ourselves with our own eyes. 2 of the girls fell from the university point in front of us. And the truck passing by crushed their head. So this is how we took the education, guys. Right? So we were just going to the university and coming home from university without knowing whether we will be able to reach alive or not. If you see somebody successful standing in front of you, sit with them and ask their struggles. I don't think so any of you traveling like this anymore. Still you are traveling like this. This is before you reach your university point. So this is the unfortunate reality. This is the very beginning. So the thing is that you have to make your own struggles. You have to take the success of your own life in your own hand. If they are able to make it, you should ask them, how did you do it? And then try to do the exactly same thing. Even if it was shared late, it still takes time to work on it. It's hardly to take, I think, 15. How much time it took you guys to complete lab report 1 to 4 hours? 4 hours. 4 hours? Yes. Oh my God. You guys are so impact. Why 4 hours? Like when you are all working together, even then it took 4 hours. Why it took 4 hours?
Because we were beginners.
You were beginners?
Yes, we understand everything, the lecture.
It takes 4 hours? And then what about you were able to? Did you also see the sample lab report I uploaded? Did you guys see?
Yes.
The sample lab report has almost all the answers, so that you know that how you are supposed to complete your lab. Okay.
Possible. I didn't get it late at morning.
12 morning? No, this is not right. Because I do remember, I'm the one actually put files in that Google Drive.
No, my friend texted me that the website now the links is open, and I in the morning I wake up 7 and I read the text on the
No, but I think some of them they say they got it very late midnight, but not 12. Before 12 o'clock, you guys got delivered. So this is something that you need to communicate with each other. So if one person is getting it, another is not getting it, so there is something, technically some issues which unfortunately I have no control over, right? I have control over the lectures. If I'm back home at my own university, I know the technical issues and I work with the student to solve them. Here I'm asking Dr. Nadeem continuously to share the link with you guys, and he has a genuine point also. He said these guys are not used to register. They register at the 11th hour. So that's why he said, unless I know how many students are registered, how can I share the link? So he had an idea yesterday when you guys done writing your name for attendance and so, and then he said afterwards he will share the link. And I do remember as soon as I was done my lecture, because they also did not share the link with me either. So as soon as I was done my lecture and I went checked my email, and they already shared the link with me. This means they shared the link immediately after the class. Why you didn't get it? I have no idea. Okay, so we should start today's class. Today's class is about programming, and I chose two programming languages, R and Python. Yes, this is very important. But before I start today's class, the students who were enrolled in the entrepreneurship, you are working on a pitch. I think almost everybody is here from that course. You guys know there's a course. I want you to please write down the group number and the title of your pitch. A few lines, only a couple lines. Why? Because I don't want the entire class to working on the same idea. So there should not be a duplication of the ideas. So if you're working on garbage disposal, one group, it doesn't mean the entire class is working on garbage disposal, right? So the ideas have to be different. Usually what I do, I make on the Brightspace side a link for the students, and I ask all the groups that before you finalize your idea, please write down the title of your idea a little bit so that the other groups can see that they are not duplicating exactly same thing. So if that 19 groups are presenting on the pitch to win competition day and all 19 are talking about exactly same thing, right? It doesn't make sense, and then judges will confuse to whom they should choose and they should not. So here, if you can write a couple lines so that we know that all the groups are talking about something different. And in that case, because we have the pitch to win on this Friday, I may think of maybe extending the date to next Friday, right? So that you make sure that everybody has a different idea. So I don't want the entire class just talking about exactly the same thing, right? So and the reason for writing this, these lines. So when the page is coming to you, you just have a look on the other titles. And then immediately you can get an idea that who's working on the similar thing. I will also have a look, and then perhaps I will contact you guys asking you that either change it, your idea completely, or just modify it a little bit so that it stands out as a different proposal as compared to your colleagues. So this is about the pitches. There's a class tomorrow. Unfortunately, my schedule, the appointment I'm trying to get, they keep on changing it. Tomorrow, the appointment has been cancelled. So we have our last class tomorrow for this course. Then next is lab report 1, and as I said, I want you guys to bring the lab report 1 today by the end of the class. I don't know if the server is working right now. Can you check? So after today's class, perhaps you can complete lab report 1, right? And then we can do the evaluation at the same time. Okay, so today is about the R programming and the Python. Anybody has any idea about R programming? Have you used it before? Have you heard about it? Nobody? Nobody has it? Okay. What about for statistical analysis? Have you heard about R programming? You know about the SPSS software and so on? And there are different statistical programming and the softwares we have available. R as such is a huge programming language that is mainly used for statistical analysis. Especially, I don't know what type of statistics you do because I don't know the background. For example, perhaps if any of you are doing PCR reactions and you have done 3 reactions at the same time to find out whether the data is reproducible or not, and then we find out the significance of the results doing t-test. Idea about t-test?
Yes.
Right? It is exactly the same thing. But here we are doing it, I think for you perhaps you might be doing 3 experiments in replicas and then trying to do the t-testings to find out the significance of the data. Here we do thousands of those data points at the same time using the R programming language. But today's class is not about using R for statistical analysis. Today's class is about using R in bioinformatics. Right? Basically it's in statistical software. I'm not teaching you statistical, I'm teaching because it is related to bioinformatics course that I'm offering, so I'm talking about R. Okay, now usually whenever you're doing programming and you're writing codes in the computer, you write those codes in the Linux programming or in the command prompt of the computer. The type of computer that we work with the Microsoft is a graphical interface. If it has nothing to do with codes and commands that you are giving, that language is hidden behind the scene. We work basically with the graphical thing. If you're working any of these R or Python programming, you have to install 2 things. One is the R Studio, another is the R package. R is actually the programming language which has all the commands and codes. R Studio is a graphical interface. It allows you to use your own laptops without transforming it to the Linux format and give the command. That command is translated by the R Studio and then R is the one that runs that command, right? So when you're installing R, you have to install this program into your computer. It doesn't take too much space and doesn't take too much time to install. Easily available. I will share the links with you. The R Studio and R, you have to install both of them, right? Once you install both of them, the next are the packages. These programming languages, they have different packages, and what packages is, you are using Microsoft computer, right? But sometimes you install certain softwares in it, like PDB writer or PDF or something, right? The CamDraw, CamWindow, Chimera, I don't know how many software that you work with, Prism, right? The statistical ones. So you install those softwares in the computer. Similarly, for these programming languages, we have we call them packages, not software, different packages. And CRAN is the software repository that stores all those softwares. From that CRAN repository, today's class will be using Bio3D package. Bio3D package for doing some sort of bioinformatics with the R program. So here is the link. And I think I have already, if you have seen the Google Drive, I already uploaded this today's lecture. So here are the links. So for installing the R Studio and the R software for both Windows and Apple. Here you have to go and download the latest version. Once you have it downloaded, and then you open once you're done downloading, should not take more than a few minutes. And then now you are starting and working with the R programming, the software. So you open the R Studio software, then your search prompt on your bottom of your computer, if you write R Studio, it will show up wherever it has been installed. You click on it, it will open. So once the R Studio is open, you see 3 panels: console, environment, and plots in the R Studio. The console is the place for writing the commands and the codes. And plots, as the name suggests, it shows all if you want to see the imaging data. Imaging means the pictures and images and plots. They will show up only in the plot panel. Environment, we are not dealing with it. It is just writing the very complicated command and learn how to write the commands. So once you have this R Studio open, 3 panels show up. Sometimes you can also have a 4th panel, which is called text editor. And for text editor, I have given the command here that you open the text editor, click on the file here, the new file, and then the R script and the text editor opens. What's the difference between text editor and console? You can write commands in both of them. Text editor, the commands that you write, you can save all the commands as a text file, right? And then later on, can use exactly the same command for whatever. So you don't have to write one line and then memorize it and then delete it or so and so. So once you have all those commands written, you can save them in the text file. Sometimes what happens for students, commands sometimes don't work. So what I do, the text file I have saved as the command, I'll share that file with you. When you open the file, all the commands are run in your R program, right? So this is the only difference. With the text editor, you can save all your commands. With console, you just write them down and run them immediately. How you run the commands, there are two options, run and source. So once you're done writing, these are the codes. All the codes are written. With the run option, if you put your cursor after each line, each command, and you click run, only that particular line of that particular command will be run in the system, right? But with source, if you click on source, all the commands that you have written so far, they'll be run. So there are different ways of writing commands. You write one command and run it. Second command you write and run it, or you just keep writing all the commands and run them by the end of it. So we do it when you are in the learning phase. It's better to write one line at a time to see if the command is working. Sometimes command doesn't work, then you immediately know that this is a line having some issues, and then you try to troubleshoot it to see why is it not working, right? So this is about the basic functioning of how the R programming works. Now the next step is you have to install the package Bio3D, and these packages are already stored in the R program. What you have to do, you have to fetch that package. So if you go to the, here I've given all the commands tools, install packages, a window will pop up like this, choose the repository CRAN, usually it shows up. And then here you choose Bio3D, because this is the package we are going to use, and then install, right? So I have given the commands in here, like exactly follow the same thing, install, and the Bio3D package will be installed in your R programming. And afterwards, you see all these shaded lines in here. All these shaded lines are the commands. So what you have to do, you have to write these commands in your text editor or in console, and then you will see what each command, what information it brings for you. So this is one thing. Now before we move on writing the commands and follow what happens and what it leads to, these are some of the tips for writing the command. Because you are working with all the codes, and these codes are very sensitive. In what sense? Whether it is a cap, you are using the small letters, you are using the capital letters, are you putting a space in between, are you using inverted commas, or you are using straight commas. So sometimes you're exactly following what is written in here, but it gives you error, right? And the reasons are that you are not following any of these tips. Right? So the commands in R are cap sensitive. If it is written in small letters, you are using the capital letters, it won't work. Right? So this is one thing that you need to keep in mind. Second thing is, I think I have given somewhere else. So while you are, as I mentioned, when you are typing these commands in your console or your text editor, R tries to help you. Programming software helps you to write that command. It prompts the words, assuming that perhaps if you write P, is when you're writing print, right? So it's better to choose the one suggested by the R rather than you keep writing or typing your own word. You know what I mean? So unless you work on this program, perhaps you won't understand what I'm saying. So while you're typing your command, perhaps if you write print, it will pop up while you're writing print. Just, the way we have spelling correction, the Grammarly, which suggests you that perhaps this is what you're writing, and you just click space and then you accept it, right? Exactly same thing happens in here. So when you write print, it suggests you whether you're writing PDD and then you accept it. So in this way, what happens when you accept the one suggested by the R, you're integrating very well with the programming language, rather than you keep writing your own. When you integrate, then it helps you to run your commands, and then you have very few errors, right? So these are the tips while you're writing your commands. So once you learn how to do it, or simply what you can do, simply copy the command lines I have written in here. So the shaded area, this bracket is also shaded. So if you just copy it and paste in your text or your editor in the console, right? But rather I would suggest, because these commands are not too complicated, simply type them out the way written in here, and then try to integrate with the R programming suggested prompts that you see. Okay, so the very first thing is, once we install the package, we are first calling the library. So we write library by 3D. I have given all the commands here. Everything, all these shaded commands are there in each line. Second one is PDB, right? And the third one is PDB, read PDB, then print PDB. All these commands that you see on the top. And once you write the library by 3D, the next thing you are asking that package to please fetch my PDB ID. What is my PDB ID? Because some of you have not done the lab report 1. In lab report 1, I think there is one of the instructions where I ask how you can get the PDB ID when you go to the PDB database and then get the PDB ID of your protein of interest, right? So this is, you should know already that my protein of interest PDB ID is 1E9Z, exactly right like this. So there is one thing which is important. You look at these inverted commas. You see any difference? What is the difference? What is the difference? Yes. So and here, look at this one. Make sure using straight double quotes. So perhaps you copy and paste this. So here there was a mistake. It has to be straight. This one, like this. And if you're copying it, pasting it, and it's not working, simply means that you need to think. All the points that I have given in here. So you should use a straight double quote rather than the italic ones. Right? Otherwise it won't work. Anyhow, so here is the Bio 3D library. You're asking to fetch the information about the 1E9Z, PDB. And in PDB database, when you go and you look at, you write 1E9Z in the search box, whatever information you get, that is visually available to you. The good thing with the programming is, it is fetching all the information which is programmed in that PDB ID. On the PDB database that we cannot see, which is not visually available to us, but it is written or hidden somewhere in the programming of that PDB ID. That is fetched by the R program, right? So here you just define the 1E9Z, and then you're asking the R to please read the PDB ID. Once it's done reading it, then you're asking it to please print it. Once you give this command, and this is what you get. Right? So here you get the information about how many atoms, for example, are there, what is the protein sequence, right? And what are the number of chains and other atoms. We'll get this information as you move on, right? So here how you can fetch the information about your PDB ID from the PDB ID database through the R programming, which is actually not available to you when you go and try to see and read the PDB files from the PDB database. So that was the thing. So you have already fetched the PDB ID. Now you're trying to read what information is contained in that PDB file. The next is you want to know the attributes of that PDB. When you write that, a box like this will appear. You have no idea what atom means, what XYZ, what SEQRES, what is helix, what is C alpha, what is remark, right? So this is the information you're getting as the attributes. You want to know what contained in each of these names. The simple is, what you have to do, type PDB, $, and atom. What is atom? You're seeing it from there. You don't know what does it mean, right? So you want to know what is contained under this header. What is the information? When you write it down, and you get all this data. So it means that it's telling you how many atoms are there, right? And what are the X, Y, Z coordinates of those atoms? What X, Y, Z coordinates?
Orientation.
Yeah, it's indirectly telling the structure of those atoms, not amino acid at the atomic level. So much detailed information which is contained in the PDB file that you cannot see when you are going to the PDB database, right? That information, hidden information, is fetched by the R program. So here it is giving you all the information about, and there are not only 13 atoms. I'm having a screenshot, very small one. If you look at, when you are in the program, you will see there are all the atoms which are contained in the amino acid will be there. Similarly, what does it XYZ mean? What does SEQRES mean? I don't know. Right? And you want to know what that contains? Exactly same thing. Write PDB, $, and XYZ. PDB, $, SEQRES, sequence resolution. PDB, $, helix. So when you keep doing it, you will get information what is in there. I want you to know how many chains are there. You want to know your protein information contained in the PDB site, how many chains are there. This is the command for it. Write PDB, $, remark. This one. This will give you information about how I have 2 chains in my protein. right? And then you should look for the proteins in your amino acid sequence or your PDB ID. Now you want to know the sequence of your PDB, the protein of interest. The command is PDB sequence, and then you write PDB. You will get all the amino acids. I have around 569 amino acids. Do you see this one in here? 569 amino acids. This is what I have written in here. So this is the same exact information you can find about your protein, and it has given the single letter amino acid identification also, right? Okay, the next is the sequence. I want to know the sequence composition of the amino acids in my protein, and this is what I get in the plot section. The three panels I talked about in the beginning, the plot panel is just showing the image of the protein. What do you see here? What A, C, D, E, F, G is referring to? These are the amino acids. Which amino acid you think is in the highest composition?
A and G.
A and G. What is A? And G? Is not guanine? Okay. Now, we did the blast search using in yesterday's class. In blast search, we did actually manually. Sometimes we may make a mistake when we are doing blast search to choose which protein of interest is the right protein for us, right? If you use R programming, it can give you a very definite answer. The R programming also can be used for blast search. Again, when you're doing individually for one protein, going to those databases that I mentioned yesterday is a good idea. But if you're working with hundreds of proteins, sometimes some projects are like that, right? And especially if you're working with bioinformatics, you do not work with one protein, one sequence. You work with hundreds of amino acid sequence and the proteins, if it is a bioinformatics project. In that case, it's better to use R programming rather than individually searching it through the databases. The one that I mentioned yesterday. The one I mentioned just to let you give an idea about the blast and how does it work, but it's better to use R programming. So what you do here, you write blast result, so you are blasting the your protein 1E9Z, the PDB ID I have mentioned, and I'm asking my R programming, please find out the proteins, more protein PDB IDs, which are having the same sequence as my protein. Right? So if our protein has been reported with some sort of identical similar sequence in the PDB ID database, and the PDB database, please fetch those ones. So here is the command, right? And then this is the information I get. So these are the six proteins, the same 6 proteins, the same. They have been divided into 3 columns because you cannot have them straight in just one screen, but they are all 6 proteins. So here you have the, again, person identity, e-value, alignment, the bit score, so all other information that we have learned yesterday, right? But again, with the R programming, exactly fetching the same information, but much better and much organized, right? Similarly, if you type head, blast result, and hit .tbl, so what you get, you see these ones over there, the attributes, the blast result attributes, HITB, TBL, raw, and what are those things? I have mentioned in here. What is HITTBL? Is data frame summarizing blast result for each related hit, right? So for each hit, the blast result are contained in the HID-TBL. Raw is a raw blast output. URL single element character vector with the NCBI result. URL and RID code. A little bit complicated. So what happens when you do any sort of search in bioinformatics using any of the databases? That search is saved in the computer somewhere, and that is given an RID, which is a code for your search. If you remember that code, keep it there somewhere in the file or say in the computer, rather than you just trying to store all the information that you have got under that RID code, all the searches, writing them down. Okay, this is the e-value, this could be the score individually for everything. You just save that RID code. So in this case, when you want to go back to your search results, you just need to write the RID code and you will get exactly the same result. So you don't have to save that search anywhere in your computer or print it out or save it right in a file. It's already saved somewhere in that database. So when you go back to the database, just write the RID code number, because they have given a search number to each search, whatever searches you perform, and just write the RID code and you get all the information again. So this is actually it meant here. I did not mention this in the last set because I'm skipping some of the exercises. I'm not teaching you all the exercises, right? So here again, if you want to know what contains in the hit.tbl, the first few hits in the table. Head is the function that shows the first few lines in any entry, such as a table, list, or array. So in this case, using head brings up the first 6 hits from the table as a result of blast out our PDB code. So here you see these are all six proteins it is talking about. These are the 6 hits. If you want, you can have more than 6 hits, but usually the first 6 hits are the ones which are more relevant to your protein of interest. And these are the questions that you need to, for example, in here, when you do your own lab report, work on the lab report, which one is the most frequent amino acid in your protein? You have to find answers to these questions. What is the bit score of most similar hit to your protein sequence? And then you have to write it down, right? So this is called the cutoff value. So what happens is, if you remember, I mentioned that you have to have high E value or low E value. Lowest E value, because high E value means a background noise. So your protein is not similar to that one. And again, in those databases, you individually try to, screen out the ones that you think are a better match. But you have to look at the E values and the bit score manually. Here, you don't have to do anything manually. If you already specify your cutoff, for example, I have given the cutoff value of 381, right? I have given the cutoff value of 381. This means for these are the length, identity, bit score, and E value. If I'm saying that I want to see something, my cutoff is 36. So the black dots that you're seeing here, these are the ones which pass my cutoff limit. Everything after that, it is shown as a red points. It's not important for me. So what I'm saying, show me the E value up to 0.00001. So if there is something higher than that, it will not show up because that is all noise. I'm not interested in the information. So here I can specify the cutoff that show me only proteins which are having a bit score up to this point. And afterwards, I'm not interested. So don't show me those protein information. It's useless information, just taking too much of my time to screen myself. So rather, you can here choose the cutoff by yourself. All the black dots are the cutoffs and the red points, we don't want them, right? For any of the criteria that we have. So here, I have used the cutoff value of 381. And after that cutoff, only 36 hits, they passed the black dots, they passed my criteria. So you can choose any cutoff value. Here I've given the example that what you should do, just try to do the same search again and again. First make up the cutoff 10, then 50, then 100, or you cannot come up with anything. Maybe 200, maybe 300, maybe 500, right? So here again, as I said, you are not doing anything individually, you are just asking R to do the search for us, right? And whatever cutoff you choose, you get your results according to that. That's all for the R programming, I believe. Right? Any questions? Any questions? So this R programming basically is a statistical software used for finding the significance of the data mostly, but it's a programming language and you can use it for anything. So I used R programming here to get the bioinformatic results. Exercises make more sense if you're doing a project in this field, right? And if you have tons and hundreds of amino acids and protein sequence that you have to compare, or you have to find related or identical ones, then all these commands, how you would use it.
I have one question.
Yes.
Does R shows if there is genome mutations? Where is the mutation exactly? This goes to the genome.
It does.
Oh.
It does for this. I did not show the commands. I will show this in the Python. How can you see which mutation is going to affect the structure and the function of the protein hub. So this you can see in Python, but in R also you can see. I kept it simple, and usually R not used for bioinformatics. After Python has revolutionized everything. People are just talking about Python. So when you have Python available, then other programming languages people are not using as much, right? Python is now integrated in everywhere. When I come to Python, we'll learn about it. I have, so I just want to know, do you agree with this? Theory is when you know everything but nothing works. Sometimes when you're working in the lab, you know everything that you're doing, you know the experiment very well. When you're running the experiment, you know that what you were supposed to expect, the results you're supposed to be getting, but unfortunately things don't work. Right? When we know, we are very well aware of the things and things don't work. Practice is when you don't know anything but yet everything works. So basically you see the technicians sometimes, they just repeat exactly the same thing over and over and they're getting results all the time. But when you ask them how did you do it, they have no idea. When you ask them what actually is happening in your experiment that you're doing, they have no idea. So this is called practice when you don't know anything and yet everything works. And when nothing works and we don't know why, what is it called?
Miracle.
Search? No, but search you are trying to find out, right? When nothing works and we don't know why is it not working. Any idea? It's called programming. Okay. Any other question, guys? You want a break?
No, ma'am.
No? No, he said he wants break. Who wants break? So, okay, now anything else other than this that we want to discuss about lab report 1? Anything that was bothering you, you didn't get the answer for, it took you so long or something? The guys who, because we already have completed lab report 1. Is there anything that you want to share with the girls who have not completed it yet? Perhaps they can complete it faster then? No? Nothing important? So I don't want to share anything with you guys. So why it took you 4 hours then?
To understand.
To understand, everybody took 4 hours. So you were all working in groups?
All are chemists.
Huh?
All are chemists, not biochemists, that's why.
Why are you taking this course then?
Just not every discipline is necessary.
Huh?
Every discipline is necessary.
Every discipline is necessary? Who decided that? You decided? I thought it's a mandatory requirement for you guys to take it. No, but in organic chemistry, you don't know about proteins? In organic chemistry? You know about proteins, right? You know about amino acids? And what else? What do you think? What was the new concept that you learned yesterday that was giving you trouble? As an organic chemist, you said it was difficult, right? As an organic chemist, what was it, something that you think that you didn't have any idea about it? Because I think yesterday what we learned, I showed you how to research is going to different databases. To anybody, even with biochemistry knowledge, this was all, everything was new for you guys. If you haven't taken it before, right? And it was like we went to the databases, we learned how to do searches, how the information is indexed, Unicode ID numbers, the accession numbers, and British score. I think all these things were new for the students as well. To hear how they store their information and how can you retrieve that information. So I assume that all the boys have done it?
No.
No, all of the, for you the same issue, the server was not working?
80% done.
At 80% done? So you are still working on the lab report right now?
In some,
But did you guys bring a bicycle laptops? I don't see how everybody brought laptop. Did you bring it? How would you do the exercise?
Lab में है मैम.
See, the problem is when I'm teaching this back home, I say back home, now it has become home for me. Students bring the laptops. They bring laptops and what I'm teaching, they immediately go in and searching. For example, and I've done this, now I give them time, half an hour, 1 hour, and they go and do the exercise. Right? And did you also go through those YouTube links that I mentioned yesterday? Did you search those YouTube links, 4 hours? Did you get the YouTube links? So those YouTube links, actually, these are the videos, like as I mentioned, it's a demonstration video. So what I'm just telling you by verbally, and I'm giving you the command. In those YouTube videos, you will see one of my students is going to the art studio, writing the command, and how, as I said, pick up the ones which are suggested by the art software, and then command, and when you run the command, how you see the results in real time, right? So the YouTube links already there. If you just go and watch the link, and you'll see how does it work. Good? Masa, any question? No questions? Should we move on to the next one? Or should we have a break? Break? Okay, break.
No break.
Go break. How you want break? Just sitting here? Or you want to go out? Huh? You want to sit here? That's how you want the break? Or you think breathe in? You can breathe in any time actually. You need break to breathe in and breathe out. Okay, so break or no break?
Break.
You already have 2-3 minutes I'm talking, which is not actually, I'm not teaching anything. So this was a kind of break I wanted to give you guys. Anything else that you think that you want to ask? Because I have only 2 more, 2 days and then tomorrow, then perhaps I don't know whether I'll be able to see you other than on the pitch to win competition day. Anything other than that you think you want to know and learn regarding anything? Regarding how's the life back over there, how the research works, how the teaching works, how the students do their jobs, anything? No? So actually over there also, the students I teach, they are from different backgrounds. They have no idea about, and this is what they're complaining about all the time when I teach them, because these students are coming from very, very disciplines. And to me, all the bioscience disciplines are same. But you know what they say? Ma'am, I am from pharmacology. Ma'am, I have done my MBBS. Ma'am, I have done the radiology. Ma'am, I'm from biotechnology. And I say, so what? Proteins? Because I teach proteins in my first course. And I say, everybody knows about proteins. Right? This is the basic that I'm. And I said, if I will be teaching this to a bioscience student, I will not be teaching it different than what I'm teaching you right now. We will start from the basics. So in that course, I teach them starting from the amino acids, their structures, their orientation, their composition, their what structure it leads to, the function, how to do protein isolation. No, they are master students, and I'm teaching them from the very beginning. But still, they are complaining all the time. Oh, man, we don't have a background. I said, I don't know like how much basic I should go. Teach this. No, because they are basically international students. They are from South Asia. The majority of them from India, Iran, Bangladesh, Nigeria, Latin America. We are having so many students now coming up from South America. India. Majority of them from India. From China also we have students. China, Vietnam, and majority South Asian universities. But now we are also having Latin America, South American. Many university students are coming from. We have some students now. Local domestic students are also coming to that program because that program is very professional. It's a very popular program.
That's university offering scholarships or invitations for.
No, they do, but the problem is they do not offer to international students. The reason is, and I ask, those usually ask me the same thing, where is there a scholarship or something, and I say that because you have shown to the university that you have too much money, you're already paying 3 times the tuition fee, why would they offer you scholarship? The purpose of the scholarship is just to help out needy student who is also smart, not only needy, smart student, so that they offer the scholarship. But the international student, if they are coming with 3 times tuition fee, it means they have enough money. So this is what I said, because you already shown them why they would give scholarship. They do not give scholarship. But they do. Students, they can apply for what's called Ignite. Scholarship is not a scholarship. It's some sort of funding offered by the university. They apply for Ignite and they get the most $1,000. $1,000 Canadian dollars. But for this, they have to work. So for example, I am working on a research project in my lab and I apply to a form and I say I'm looking for a United student. And at the same time, another student also apply for that program. And if we match, so he will email me or I will email that person. And then if you are on a project, then that person can work for me. Then that person will be paid by the university. This is a kind of work, not a scholarship as such. They don't have any, unfortunately. International students, they don't have a scholarship. For domestic students, there are tons of scholarships. They have the biggest one, which I always recommend, and I have had many students to get, is called NSET scholarship. And you get around, it was $6,000 one time, now they are getting $9,000 for 4 months. So what happens during summertime, undergraduate students, they work just find a supervisor, and it's very common, very popular. The undergraduate student, they find a supervisor, and then both of them, they agree to work with each other and agree on a project. Then they apply to NSET. NSET is federally funded scholarship program, and they apply to NSET. And NSET have a criteria. For example, that 300 students are applying, out of 300, only 121, for example, are getting the scholarship. to just see the performance of the student, basically in high school, because this is undergrad, that how the student was doing in the high school. If the professor has good infrastructure and the project is good, they choose them and then they pay them from May, June, July, and August. 4 months they get $9,000. Out of 9,000, I think 7,000 is given by the federal government and 2,000 coming from supervisors' funds. So it's a very good opportunity. Like 9,000 is your domestic students entire year tuition fee, more than tuition fee. For tuition fee, they pay around 70,000 or something, but now they're making 9,000, and it's only for 4 months they're working in making. And sometimes what happens, the professors usually have funding, and if they find a very good student, the answer student they partner with, and they find also really good student, then they ask them to work with them continuous basis, and they keep paying them for the entire year. So 9,000 they make in summer, but in the fall and in the winter term they still can decide to work with the student, with the professor, and then the professor pays them. Right? So this is the answer scholarship for the undergrads. And the other scholarship, yesterday for example, I was just marking some of these scholarships for OGS, Scholar Ontario Graduate Studies, and the CIHR scholarship, and because I am in the grad committee, and in the grad committee whenever students apply for a scholarship, those applications come to us. And then we all faculty members sit and then we decide, we rank them which we think that should get the scholarship, number 1, number 2, what are the priority basis, right? So I just did some ranking, it is due on today's 7th, no, today's 6th. Yeah. Tomorrow is a deadline. So I already have completed and I submitted to the search committee that look for this. So this is what we do all the time. Right? So it's enough break. Yeah, breathe in and breathe out. Fine. Can we move on to the next one? Okay. The next is the Python. Any idea about Python? Why is it called Python? Because of the snake? Because of what? Because of the snake? Because of what, guys? What is Python? Why we call Python? It's a very famous name. Have you heard this name before? Or in what respect? Like, do you know the meaning of it? Literal meaning of it? Like, you're asking, you're telling me. Nobody knows.
Scientist name?
Scientist name Python. Okay. What else? Haven't heard this name before? I think there was a very famous Hollywood movie where they talk about this many times. Somebody said here something. One of the boys. What you were saying something? So you were just guessing? I thought you know something about it. Python is actually the name of a snake. It's a very venomous snake. And I don't know, I didn't find time to search that why is it called Python. This is actually anaconda. Any idea about anaconda? Have you heard named anaconda before? Where did you hear about it? National Geographic. What it is telecast here in iccbs? As a documentary or what? So it's actually there was an Hollywood movie where it was all about that snake anaconda. At that time we learned the word anaconda. Right? Okay. Okay, why Python is so famous, and I have given the reason in here. Python is a very simple and easy to learn programming language. You don't have to have a background in organic chemistry or biochemistry or whatever, right? So anybody with any background can learn this programming language. Very easy to perform and very easy to run the commands. You don't need too much space to install Python in your computer. And here, anybody, if you know how to run with R programming, for example, perhaps you will find for some of you the code is not working. As I mentioned, if you're not following all the tips, the commas were not inverted, or that you're giving a space, it's not happened, so and so. So you will find many issues while running the commands for R. Here there is no such issue. You just need to copy the command that I have given in a different slide, copy in your Jupyter notebook, and then it should work. You hardly have any issues unless you're doing something fundamentally wrong. Otherwise, Python works. This is very simple to perform, very simple to install, very simple to learn, and run the command. And Python is everywhere. It's just using it in just like algorithm, just like AI is everywhere. So if you are in the programming, doing something in computer programming, Python is everywhere. So Python, a person like me, I have no background in it. I didn't hear anything about it. I am teaching Python now. because it's so much integrated in bioinformatics and the bioinformatics in bioresearch, the biochemistry research I do. Python is, that's why it is getting so famous. Initially, I didn't have any exercise based on Python, but because realizing that it's very important, I should have something on Python rather than R, I decided to have Python exercise. And it's very simple. We do exactly the same thing as we did with R, but much more different than before. So here again, as I said, it's a beginner-friendly syntax. Like even without any knowledge and any background, anybody can learn this programming language. It has powerful libraries. What does it mean? The packages I talked about in the R program, they also have very strong packages. So they already have, make those softwares and install in their Python thing. You just need to download the software. Basically, software is a help. The way that we have ChatGPT or so. So we just write the command and ChatGPT does everything for us. Similarly, these packages, you just need to download it, write your command, and then the package will take care of everything. That is one of the reasons you don't have to learn so much to use Python, because things are built in. It can be automated very easily, can be integrated into many systems, and cross-disciplinary support, as I mentioned, that anybody with any discipline can use Python. For multiple reasons. I'm teaching you here only with respect to bioinformatics, but you can think of anything. It can be used in banking, it can be used in imaging, can be used in the life science research, can be used in the organic chemistry, for derivatization of their compounds and so. Like it has, as I said, varied discipline application, this Python. I'm only focused here on the bioinformatics, so this is what I will talk about. But it has much more application than that. Okay, so we use Bio3D for our programming. Here we are using BioPython package, and what all it can do, I've mentioned in here: sequence handling, alignment, phylogenetics, file parsing, access to online databases, structural biology, and much more. If you want to know more about this BioPython, I have the links in here. You can click on it and then. Okay, so now what you have to do, as like with R, you have to download the Python. And again, Python doesn't take much space, easy to download. So once you download it, so you just use the word Anaconda Navigator. Okay, so once you download it, the way I showed you that different panels show up in the R1, in the R programming, the text editor, the console, the environment, and the plot. Similarly, here also you need some sort of graphical software, and for this you have to use this notebook, the Jupyter notebook they say. I will show you how does it look like. It looks like an Excel sheet. So you have to, once you're done installing your Python, and the next is you have to open the Jupyter notebook and then launch it. Once you launch it, I don't know if it can capture it well. So here, it looks like. So you have this toolbar in here, and just beneath it there is a column. There's a huge column. That is the column where you write the command. So this is how it looks like. The Jupyter notebook. This is how it looks like. I have given the command, the steps here, that how you should make a folder in the Jupyter notebook. Once you open the Jupyter notebook, you make a folder with your name, right? And then double click on it, select Python, just follow these instructions and install the BioPython package in here, right? These are the commands that you will be using. And then once you're done writing your commands in this column in here, you click on the run selected cell. When you run the selected cell, that command that you have written down, it will be run, right? So everything is so simple. It's written in here. You just need to follow the instructions in here. Write down your command in one of the columns, click on run here, somewhere in here, and this one in here. When you click on it, it shows this one in here. When you click on it, it shows run selected cell. When you click, the command will be run, whatever command that you're writing. So here now I'm giving you the commands, how you run the command. For example, you have the nucleotide sequence, right? And you want to know what that nucleotide sequence is translated to, what amino acid sequence. Sometimes, anybody is working with the genomes or DNAs or so, not all the DNA sequences are translated to amino acid. Is it right?
Yes.
Why? Why not all the DNA sequences are translated to amino acids? Exactly. So because of what?
Those are regulators, they regulate the gene.
So for example, if I'm looking at nucleotide sequence, and based on the codons, can I specify this is the protein sequence would be? By just looking at it, I translate it manually? And it will be accurate?
Like this you cannot find it.
So, yeah. So see, you will hear that. So if family is looking at a nucleotide sequence, like this is a nucleotide sequence written in here, right? It's not the amino acid sequence, it's the nucleotide sequence. And I know, you know the codons and things?
Yes.
You know the concept of organic chemist, but they don't know. Right? You know the codons? You know nucleotides?
Yes.
Nucleic acids, you know. So you know the RNA, DNA molecules, they're consisting of certain nucleotide bases, just like proteins are consisting of amino acids. How many amino acids are there in the protein? 20. These boys, organic chemists I'm asking. How many amino acids in the proteins? Huh? 20? That 20 is standard amino acids, right? How many nucleotide bases in DNA? 4 nucleotide bases. These guys know? Right? Okay. So you see here ATGA, ATGAA, ACTCA. These are the nucleotide bases. What A stands for? T. Now asking the boys, I know you guys are confused. What is G? Guanine is we learned yesterday, right? And T is? Thymine. What is C? Okay, if instead of C I have U here, then it is? Then it is RNA, right? So here we have these nucleotide sequences. Now, perhaps you also know that a set of 3 codons specify one amino acid. You know that? So, for example, a codon of ATG will specify which amino acid. Any idea? Imagine it's specified an amino acid. Now I know the sequence and I know that which codons, set of codons specify which amino acid, and manually by looking at it I'm just writing the amino acid sequence. And I'm assuming if nucleotide sequence specifies this is the protein, it will be translated. But as one of your friends mentioned,
It's right that the codon, most of the time the codon is nucleotide, but in mitochondria the codon is for nucleotides.
in mitochondria, there are some exceptions, yeah, because mitochondrial DNA are a little bit different when you talk about them. But here in general, a set of 3 codons specify one amino acid. But as your friend mentioned, that by just looking at the sequence, and if I translate it manually, it is not exactly what the DNA is specifying. No. Because it is decided by the nature. There you have to follow certain rules. Not all the nucleotide sequences are specified into the amino acids. And there are many reasons for it, right? As we mentioned, one of the reasons what you said, they are not...
Madam, they are not coding. That's why they regulate the gene expression procedure inside it.
Sometimes they are regulators of the gene expression. Yeah. And then there are some gaps also in between, right? And sometimes we don't know when the translation of a protein stops at a certain stage, right? So by looking at the nucleotide sequence, we manually, even having all the information, accurately specify which protein will be translated, right? So it's a huge thing. Here you need information, here you need the knowledge, here you need the background to accurately translate what the sequence will be specified into the nucleotide sequence. But Python can do it for us. Python has all that knowledge, all the background, all the degrees. So you just need to write down your command there, specify the nucleotide sequence, and it will exactly tell you that this is the amino acid sequence of that nucleotide. So if that nucleotide is translated, this is how it will be translated, right? If it is not, it will let you know that your nucleotide cannot be translated into anything, right? So here, see, like by just simple, in few seconds, without having any degree, any background, anything in that, how it is translated, I just give this command to Python, and then Python immediately translates it. And if you remember, this is the sequence I'm using for the demonstration purpose for my protein, that the one I mentioned in the yesterday's class also. Okay, the next is BLAST, the translated sequence. So now this is the sequence I have got. This is my translated sequence in here, and I'm trying to gather more information through Python about that sequence. So next I'm asking, please BLAST that sequence. BLAST that sequence, again the same thing. Let me know which other proteins have exactly the same sequence, right? So Python, perhaps I can get more accurate data that I can get manually or through R. This is the set of commands that you have to just simply copy it. You said the huge commands from, I will break it down, how does it work in one of the next slides. So here you just need to copy this from here till all the way here, and copy it in the column in the Jupyter notebook, click run. Run is selected scale, and you will get the data in here. So this is the data that you're seeing. This is your data in here, right? So you have this is a one protein sequence that it has aligned with. You see another one, the third one, fourth one, and fifth one, depending on that how many you want to see, right? So this is called the BLAST, the translated sequence. So exactly same thing that you did with the R. You can also use Python for characteristic of the identified match protein. I want to know the protein that they have identified is the most closely related to my sequence. What are the parameters? What are the characteristics? What are the other feature of that protein? For example, I want to know the molecular weight of that protein. I want to know the isoelectric point. What is isoelectric point? PI? Number of electrons?
The point at which the protein with equal positive and negative charges.
The what? Sorry? The at which the protein is equal. Sorry, say it again.
The negative and positive charges will be equal.
I do not, because so many people started speaking at the same time. So you're saying the charges?
When both charges are same.
When the charges on the protein are same.
Yes.
And like in which situation? Like which environment they're talking about? Huh? Inside the cell? In cytosol, this means that when the charges or number of charges on a protein are identical, then what will happen? If the charges are identical, and I don't know what you mean, negative and positive charge?
Yes.
This means there are equal number of negative and positive, like 2 negative and 2 positive. This is what you mean by identical. Then what will happen? It becomes neutral. And then deuteride. Then what will happen?
It will have a positive charge and a negative.
Okay, it becomes deuteride, then it will result in what? When a protein becomes deuteride, then what happens? Huh?
It precipitates.
It precipitates and it stops moving under the influence of an electric field. So what happens when you are doing, how can you find out the isoelectric point of a protein? You load your protein on a gel. That gel contains a pH gradient, right? And when your protein will be having, when it starts migrating or either positive charge or negative charge, till it reaches to a pH when the number of charges on that protein are equal or become neutral. The neutrally, the protein has actually no charge because all the positives are cancelling the negative charges and your protein becomes neutral. When it becomes neutral, it does not move anywhere in the electric field, right? And this is the criteria used for many isolation techniques where the proteins are isolated. One of the criteria is when you want to precipitate your protein, the protein of interest, if you know enough about it, use a pH where you know that there's the charge, net charge of the protein is 0. In that case, the protein will be precipitated very easily and you'll be able to isolate it very easily, right? Similarly, if you want to try to isolate the same protein using the isoelectric focusing, or where you combine the pH, the electrophoresis and the pH gradient together. If you want to isolate your protein like this, again, just load it on a gel which has pH gradient. When your protein reaches to a point, a pH, where the net charge on the protein is 0, it will stop moving in any direction, right? And then you can excise that band from the gel and purify your protein, right? So this is a criteria which is used to do many things with the proteins. So similarly, if you want to know the molecular weight, the isoelectric point, amino acid and nucleotide composition, much more about your protein, this is the commands that you are giving. So here you are asking to analyze the protein, molecular weight, find out isoelectric point, amino acid composition, right? And then this is the sequence I have mentioned that I want to know about this. Once you're done finding out everything, then print molecular weight, print isoelectric point, so and so and so, and this is the data, right? So here I have the information about the molecular weight, isoelectric point, amino acid composition, right? So this is how Python has made it easy for you. Within few seconds, you can get the data immediately. Okay, the pairwise DNA. Okay, now what you're doing here, you have 2 DNA sequences. You see these sequences are similar to each other? Are these sequences similar to each other? No, they are different. So what it does, what this function does, pairwise DNA alignment, it compares and matches the characters of two DNA sequences to identify similarities, differences, and the possibility of homology. So, as we just discussed, for us, with humanly nature knowledge that we have in the background, all the background, we are not capable of translating the DNA nucleotide sequence accurately by saying that, okay, this DNA sequence will be for sure translated to this protein amino acid sequence. Now, if you are asked to compare two DNA sequences, when I'm looking at them, to me they look very different, right? But just looking at them, I cannot decide. So what the Python is doing, it is doing all the background analysis that actually we have no idea about and we have no personal background in it, and is doing all the analysis and it's telling you whether the two DNA sequences are similar or not, and if they are similar, what is the criteria for similarity and where are they similar to each other. So it will not only give you the nucleotide sequence, it will translate the sequence, and based on that sequence, will do all the background search using different databases and will give you an idea how much similar they are, right? So the highly matched protein or any protein. So here, like I've given all the information if you just follow that. It uses a scoring system to assign positive scores or for matching positive and negative scores, so and so, right? So what I'm asking you, write down your DNA alignment matching score. How would you get your DNA sequence? You have any DNA sequence? You are using only the amino acid sequence I have given you. If I ask you to translate that amino acid sequence to DNA sequence, can you do it?
Yes, ma'am.
How?
I wrote with the class.
Can you?
We can do manually or by simple.
So, here to find the answer to this question, so if you can translate the amino acid sequence that I have given you, 50 amino acids, 50 divided by 3, how much? Divided by 3. Divided. 16 or something. So you will be having a DNA sequence with only 16 or 17 nucleotides, right? So use that DNA sequence to carry out this step of the exercise. Okay, again, if you want to know the PDB ID of the matched protein, this is a command that you should be using. See how the command system works in Python. So here you are asking Python that from BioBlast import these files, right? These two files that you see on the top. And then the next, whenever you see this number sign means you are giving a command, a new set of command to Python. So here if you look at this number sign, define the protein sequence. So this is a sequence that I am using in the straight inverted commas. Next command I am asking, please run blast search against the PDB database. The third command I am asking, when you've done that, parse and filter PDB ID based on E value. If you want, you can filter it based on bit score. If you want, you can filter it based on length, or whatever you decide. So actually you are communicating with Python. You're saying first import these files. Then once you're done importing, define the protein sequence. This is the sequence in here. Then you are giving the command, please now run blast. Once you've done that, then please parse and filter the PDB ID based on E value. Once you've done all this, then please display the results. So this is how you write the command. So you are actually communicating with the Python, asking it do this, and finally print the results or display the results, and these are my results. So it is giving me all the PDB ID of the files where they find this sequence. These 50 amino acid sequence are shared by all these PDB ID files. Right? So they are all together how many? 14. So in my case, how many PDB IDs I see? 14 of them. Describe the PDB ID of your identified protein, which is 1E9Y, this one in here, and do all the PDB IDs, describe the same protein with different variants. So, this is something that when you load the entire command, the results, it will let you know. Right? So here are my questions and here are the answers. So you have to exactly do the same thing. So you understood this is how simple writing command is. In R programming, we are not communicating with the R, but here you are communicating with the system. You're asking them, fetch this file, search this amino acid, then do this. When you're done, then do this. When you're done, then do this, and then finally display the results. Again, if you want to know the sequence of the protein that you are interested in, 1E9Z, you will get the entire sequence, and this is a command in here. Let me go to that mutation question that she was asking. Okay, multiple sequence alignment and uncapped sequence extraction of matched protein. Again, if you want to do the phylogenetic analysis in multiple sequence alignment, and I think I mentioned yesterday, MSA or phylogenetic analysis basically gives you an idea about the evolutionary partner of your protein. That your protein is related to evolutionarily with which proteins, and that information you can get through MSA and the phylogenetic analysis. Something similar you can do in the Python. So this is the set of command that you have to copy. So you just simply need to copy these commands, write in Jupyter books notebook, and wherever you see this yellow thing, here you have to write your PDB ID, not mine. For example, here the yellow thing, you write your PDB ID. Here I'm writing my sequence, you write your sequence, and you will get different results. Here you can use this sequence as yours, your amino acid sequence your reverse transcribe to the DNA, and this one you can use mine. This is yours, use yours, and this one is mine, you can compare. So wherever you see this yellow thing, here you have to just change your PDB ID, your sequence, and then you'll be able to get results according to your protein. Now what we have done so far, just looking at sequence, the molecular weight and isoelectric points and so on. So as I said, Python is a very strong programming language, and it's very good with the imaging and the structural determination. I want to see the structure of my protein. I have no idea how the sequence looks like. The 50 amino acids I know, and I'm asking it, can you please also let me know the 3D structure of my identified protein? So this is a set of command that you have to write, and this is the protein structure. Immediately it will show you the protein structure based on all the background information the Python has access to. Okay, this is a question about the mutation. Now you want to know, okay, here I'm just giving you single isolated commands. All depends on your project. If your project is about finding the impact of a mutation in a protein, you can choose any of the commands and then move on and then do the next step. So I'm just introducing you that what you can do with Python. It's not the entire thing that you can do. You can do much more than this one. Here again, if you want to know your project is about, look at the impact as a protein which is highly mutated in a cancer condition, in a cancerous physiologically in any of the tissue, and that protein is highly mutated. You want to know what happens if you induce mutation in that protein physiologically, and then how it changes the structure plus the function of the protein, right? And you can induce mutation at any point in that protein, just for research purpose. Or if it is already reported clinically that protein is mutated at amino acid number 10, 15, 20, you can induce mutations yourself and then see how it changes the structure and the function of the protein. So for this is a set of command that you have to write. And here I'm asking it to change the, induce a mutation at amino acid number 10 in this protein, 1E9Z, the protein which is reported in the PDB ID 1E9Z. I'm asking please induce a mutation in number 10 and then let me know how the sequence look like, right? I don't have the slide maybe, but it not only gives you the sequence because you changed it from lysine to, what is K? What is K?
Lysine.
Huh? L is lysine. So I change lysine to, what is K? K is lysine. Then what is L? Leucine to lysine. What is arginine? Huh? R is arginine. Okay, so here the leucine is transferred to the lysine. And not only this, on the next slide, which I don't have it in here, it also shows you how the structure is changed of that protein by one single amino acid mutation, right? If you want a mutation, I'm having a question for you. I mutate at number 10. I'm asking you to do the mutation at number 15 and then look at the structure of the protein. How is it changed from the native structure? This is the native structure, right? And here you can rotate the protein. It's just not the 1D view that you can see. You can rotate protein up and down to exactly see where the how the native structure looks like. But once you induce the mutation, you will see the structure similar to this. But again, you have to animate it here and there to see how the structure has been changed. I will show the impact of mutation in the chimera also tomorrow. In chimera, I will show you how when you compare two proteins after mutation, how the structural comparison looks like and how they are different from each other. I think that's the last one. And that's it. So what you have to do again, submit your lab reports, please, and then somebody has to evaluate that lab report. Get it? Any questions? Anybody get anything or no? Just going from the head? Going on the head? Yes?
Can we submit that lab report on Friday or 27th?
Which lab report? Every day you have to have a lab report. This one? It is too much. You have to just copy the commands. You have to simply copy the, I think I have 9 or 10 slides, right? I have shown you 9 and 10 commands. You just need to copy the command in the notebook, Jupyter notebook, and the yellow portion that I have given, you have to replace that with your amino acid information. That's all you have to do. It hardly will take, I would say, 15 minutes of your time. And then the results that you're getting, you just need to take a screenshot of it in the Word file. Right? Even you don't have to type it yourself. So just take a screenshot. Should not take more than 15 to 20 minutes of your time. Yes? You don't need an example report. I already have given the answer to some of the questions already, right? And I already have, for example, the structure is shown already, that your structure should look like this. I'm getting 14, for example, you're supposed to be getting according to your 14, for example, PDB ID is similar to the one that I mentioned. So you'll be having, I already have given the answers. I don't find any need for sharing the sample, and I don't think so I have a sample lab report for Python. For the first lab report I shared, because it's the first time the student has submitted, they have no idea, but then afterwards it's exactly the same. How can you get the DNA from amino acids? Some of you were saying that they can do it. Okay. Who was telling me that you can transform the amino acid sequence to DNA or DNA to amino acid?
They can do by using class.
Huh?
They can do by using class.
You know about the codons? You know about the codons? You know that set of 3 codons specify one amino acid. So if you are transforming the amino acid sequence to DNA sequence,
You have to do it manually.
manually I'm asking, yes? That's what I said, you have 50 amino acid sequence, right? So you have to basically write, I think it will end up to 16, 17 nucleotides that you have to find.
There is no software something like which can convert it.
There is one, but then I did not teach you. It's better just do it here manually and then use that sequence, only yours. The second one you can use mine when you do the comparison between 2 nucleotide sequence. Yes?
I have a question. Step number 5.
Huh?
Can you please go to step 5?
Step 5? This one?
The last question was how can we find out this question?
Do all the PDB IDs describe the same protein with different variant? What does it mean actually? What this question means? What is variant? Any idea? Different isoforms and mutated forms, right? So what the question is asking, do all the PDB IDs describe the same protein with different variants? What does it mean actually? Any idea about this question?
Version of the same protein.
But with different mutations.
You are asking
Yeah, so it means if they are describing the same protein with different variants, it means the same protein but little bit mutation in those proteins.
Yeah, the allele. It has different alleles.
LA?
Alleles.
Alleles, yes. So a same protein but different mutations. It's called same protein with different variants. Same protein but different isoforms, right? So here, how can you find this out? Any idea? Mesa, how can you find out? Do all the PDB IDs describe the same protein with different variants?
Last, and I went to sequence. From sequence, I went to the genome details, and I got all the information.
You see that? This is how you're going to do it. But because I did not teach you, just simply write no. The other option is you just go to all these PDB IDs, open the files, right? And then learn the information they are getting. They are telling you if it is from the same bacterial species, Helicobacter pylori, and they mention it in the PDB IDs. If you open these files, whether they are the variant of the original protein from Helicobacter pylori, right? But it's become too much. If you can do it easily, just go ahead do it and open all the files one by one. If not, leave that question.
Ma'am, in the last previous lab report,
question can find out the mutation in your PDB page. So is it a relevant question? That one?
No.
Because
No.
mutation.
PDB file will let you know all the mutations have been reported in that particular protein. Right? But this one is different than that protein. It's just simply asking you that all these proteins which are showed up in here, they are all same proteins basically, or they are different proteins. But if you have to go and open the PDB ID files and the PDB database for that protein. But what I'm asking you, just leave that question. If you can find out answer easily, is good. As I always ask a student, look, this is what I showed you, right? Do not stick to what I showed you. Your main purpose is to learn, right? So that you can practice it independently and use this information later in future whenever it is needed. So don't stick to what I am asking you. You can do your own experiments. Try to find out much more than I showed you here, right? So I showed you all these files. Click on each file one by one and see what is contained in there, right? So I'm just showing you for the purpose of giving you the credit for the course. But nobody is stopping you to learn using the same command or different command. For example, I said filter PDB ID based on e-value. You can write based on bit score and see what the result is. You can write based on the accession numbers. You can write based on the length, right? The threshold, you can use anything. So it's up to you. Try to explore and see what else you can learn and what information you can get. In the interest of time, I can show you only limited information. But that's not all these programs are about. Right? So here I'm just giving you basic information. As long as you have the basic information, if you are required to use this information for any of your projects, you know how to explore it further. Get it? Anybody? Yes?
Tomorrow is our NMR exam.
Sorry?
Tomorrow is our NMR exam.
Tomorrow is your NMR exam?
Yes, to create our course.
So you want also the bioinformatics exam?
Students.
Who's teaching the NMR?
Actually,
He is here? No, but he is in person, he's teaching you?
yes.
And when is the class?
Classes are already done, but tomorrow is exam.
What time?
9 o'clock.
9 o'clock? How can you take this course then? There's an overlap.
You told us yesterday that Wednesday there was been off, so you have
But I just told yesterday, you have this exam for a long time, right? And also the flyer advertised the classes from Monday to
5,
Wednesday.
6, 7.
So there's an overlap in the two courses. So it is from 9 to what time? Like how many hours?
1 hour.
1 hour only. Like from 9 to 10? That's it? At 10 o'clock you can come here. Huh? So okay, when you will be done the exam?
What about doing?
Sorry, what?
10:30.
10:30 you can come at 10:30, we will start 10:30. So it's better to start class late rather than not having any class. But do you have any exam after my class?
No.
Okay, then you are relaxed. When you are done your NMR exam.
But I have request to permission for the submission of the lab report.
When you want to submit lab report? Next day? I can give you time till next year. Till I come back again. How about that?
Friday.
Friday, then Friday you have your pictures also.
Thursday.
Thursday you have pictures?
No, Friday.
Friday is pitch. So the lab report for today. Okay, everybody has, the entire class is taking that NMR exam?
Mostly.
Who is not taking it? Can you raise your hand, please? So these are basically the girls here. You are not taking it? You are already behind in lab report 1, right? So you guys, you finish your lab report 1 and 2 by tomorrow, right? And then these guys, I can think about them. Even if I give them next time when I come back, you will be able to finish it, right? How many hours you need this time for this course? 4 hours? Huh? 5 hours? Here you just need to copy paste the commands. That's it. So for you, the ones who can complete the lab report until tomorrow, please try to do it tomorrow. The ones who cannot, I can extend the day. Right? But what it means that as soon as you done your exam or whatever, finish it up. So don't wait for me to give you a deadline and say, ma'am, you didn't give me the deadline, that's why we did not finish it. Don't wait for the deadlines. Right? So as soon as you are done with the NMR exam or course, whatever, and then work on the lab report and bring it in the class. But today, how many have brought the lab report? One. You have brought it, and I don't know what to do, the ones who have not done it, because it has to be a peer evaluation. We still have an hour, and I was thinking that an hour I will just distribute the lab reports among you guys and you do the peer evaluation. But how can you do peer? You guys do not come prepared at all, I'm telling you. How can you do peer evaluation? Nobody brought the laptops. Peer evaluation, you have to look at the answers to the student who is submitting the laptop. Basically, you just want credit showing up in your mark sheet for this course, that's it.
It's one of the
You come up with your own rules, right? So this shows me how much serious you are. Coming to the bioinformatics lab without laptops, lab reports are not done. How can I complete the and give you the credit for the course? Because the way it works, you have to bring the lab reports, then I give you, I distribute those lab reports anonymously to other members. They do the evaluation right now. This is the reason I have given 4 to 5 hours for the class.
Sorry, can I say something? Sorry.
No, but then it will become a mess for me. Because the next day I don't know who has been evaluated, who is not, right? If I know that everybody is bringing it, and then I know the entire class is done. Otherwise, it's a mess. It's a never-ending story.
Can I say something? Sorry. I've been here visitor for 1 month.
Sorry, what?
I've been here visitor for 1 month. Not everyone is equally to other one. Sometimes you can find the students, they are active, they are well enthusiastic to learn, but unfortunately their laptop is broken, or they don't have laptop yet, or they have something. So in this condition, they can't bring the laptops because their laptop is not that efficient. They are low.
I understand what you're saying. Actually, this is not the first time I'm hearing all this. The students, they come up with these, sometimes excuses, sometimes there are genuine reasons, right? But whose job is it to fix it? Is my job to fix these problems? You know how many issues I'm facing right now when I'm still coming and teaching? You know how much badly I was sick when I was teaching entrepreneurship course, but I did not take a single day off. I didn't want to teach actually bioinformatics because I had other commitments that I was falling behind. But when I see there's so many students enrolled, I thought it's my responsibility to come and teach, right? So the thing is, let's not thank you. You just learn from here that, when you have to do something, you have to do it, right? If a laptop is broken, then don't take the course. Then why are you taking the course? If you cannot complete the criteria,
some courses
but yesterday you took the class. I didn't mention things like that. Right? And I said you have to do the peer evaluation. How can you do peer evaluation without looking at the answers of your peers in the laptop? Unless you are very good with the cell phones. Right? So I have no idea how to complete it because lab report 1, some of you have done it. If I take that lab report 1 and distribute it to others and ask to do peer evaluation, I have no record of who has submitted it, who has evaluated it, right? So unless the entire class brought it, I know everybody from here to here has brought the lab report and all those lab reports have been evaluated, then I know, okay, lab report 1 is done, right? And then I can write down the answers. But here, in fact, done with half of the class bringing tomorrow. Then again I have to ask who has done it, who hasn't done it. But this is a peer evaluation. Have you done peer evaluation? Because it has happened before also, right? So it's not very systematic, unfortunately. So you have to, yes.
Ma'am, tomorrow we all can bring the hard copies of our both exercises and then we can exchange and do the...
See, the point is like, I see this type of suggestion always. I don't know whether you have talked to all the entire class and you are talking on behalf of the entire class. You might bring it tomorrow, but the rest of them, they will say, no ma'am, could this happen, that happen, I couldn't bring, So there are so many ideas I also have in mind, right? But the problem is who's going to follow them. That's the issue. Okay, so I have no idea what to do with this lab report. But what I'm suggesting right now, the ones who haven't completed lab report 1 and 2, I'm asking you, complete 1 and 2 tonight and then bring them tomorrow. And then you guys who have, you have some, you said you are the one having the AMR. They don't have the AMR, right? So in that case, as soon as you're done with your AMR, work on the lab report, right? I'm here on a very limited period of time, and I'm the one who has to give you the marks for the course, right? So if you are not working with my, the time availability, unfortunately, you will be at a disadvantage. I'm not losing anything out of it. Right? So you have to please cooperate and then see how quickly you can complete the lab reports, bring it down, and then we have to, last time also what happened is students were bringing the lab reports and they just completed 4 steps and remaining 6 they say it's not working. That's how they submitted the lab reports. So please this time don't submit lab reports like that. When you're working on the lab report, make sure that you're completing all the steps that I have mentioned in here. Right? And then because the peer evaluation will be also looking at all these steps, so just try to genuinely learn something, follow the instructions, so that when you get the credit, it's very authentic. Right? Did you go to that site that I mentioned where I have uploaded all the YouTube links and the package for this bioinformatics? I said you can link that site with your LinkedIn profile. Do you have LinkedIn profiles, by the way?
Yes.
All of you? It's very important that you have LinkedIn profile and it has to be on display. For example, my profile is hidden. I don't want my profile to be known. I don't need to. But for you guys, it's important that you have LinkedIn profile up there and also it's updated. Updated, you have all the information, whatever courses you are taking, whatever level of your education you are right now, the research you have done, the papers you have published is always there. Because when you're applying for jobs, the employer is looking at your LinkedIn profile. Right? And I don't know here, I think here also they look at your LinkedIn profile. Back over there, yes, it's very common. If you don't have LinkedIn profile, they don't know anything. It's that whatever you're writing in your CV is not authentic. And it's very important that you provide a direct link to the courses that you have taken, direct link to the paper that you have published, direct link to the institute where you are working. It makes it more authentic that, okay, you are a real person, not an AI generated person or something. Okay? Anything else? Mesa? No suggestion? Numera, suggestion? Numera always comes up with suggestion, but I always think about, this is a suggestion, I don't know the entire class at least. So if you are coming up with any suggestion, better ask all the students and then see how the problem can be solved. I have no idea how to fix this server issue. And I don't know what is the issue. Because I am on the internet all the time, I never find the iccbs server down anytime. Huh?
We have computer lab upstairs.
Here in LEJ?
Yes.
But it works or not?
What will be done? Add the LEJ, then you can ask the officials.
No, but that lab.
Yes, they can arrange.
It's working?
Before that, we took the Linux class in that, and they have arranged these computers for us. And if you wanted, they are using the office now.
No, but but somebody has to talk to them?
Yeah.
Like who? A student can go and talk to them?
Yes, we can also at your behalf.
Yeah, you can. If you have some issues with your laptops are broken or so, as she's saying that you have a computer lab up there in LEJ, so you can go and use those computers. And you can say that because this is a requirement for this course that you have access to the computer. If you don't have your own, this is what students usually do. In the library, they have computers available. So you just go and use those computers. In case they do not give you the access, then you can come and talk to me. So, when you are, this is what I also suggest to this, I take everything as an opportunity to teach people. So when I'm saying something, don't take it as, criticism or something. I do exactly the same thing when I'm working with other students. So when you are coming up with a problem, for example, you pointed out this server thing, just telling the problem is not enough. Also come up with the solution. What do you think would be the solution to that problem? And if I can help you to achieve that solution, yes, I would do that. But if you're asking your server is not working, there's nothing I can do. But now she gave the solution. She said we have access to the computer lab up there. So in case when you mentioned the laptops are broken and so, again, give me the solution for it. Solution is that the laptops are available and on the second floor, go and use those laptops. Yes, if they're not allowing you to use that laptop, you can talk to me and then I can ask them that you need to provide this opportunity, the facility to the students, so that they can do something about it. So for example, you don't have access to the Google Drive, I can ask them, give you the access. Beyond that, what is, if you're not suggesting any solution, there's nothing I can do about it. Right? So whenever you look at a problem, always look at a solution also. This is the motive behind your pitch to win competition, right? So you are looking for the problems in the society, the biotech problems. Don't go for the social problems, and then you are suggesting a solution to that problem. And I need that paper, please. Where is their paper where I ask you all to write your pitches, your ideas? Where is that paper? How far it has gone? So everybody from here to here, they have written it already? Those ones? What about the one in the back? Can you share the paper with them?
When do we have this competition?
I'm thinking on 9th of this Friday, but I think somebody was saying that you have exams on 9th. Anybody, you have exams on 9th of January, this Friday? No exams? So I was thinking 9th, but all depends on, I'm in contact with the judges. I have found 2 judges so far. I'm trying to have 1 judge from the industry, and I'm asking Dr. Gavamar also, I need to talk to him. If it's not possible this Friday, then maybe the next Friday, 16th January, we'll have the competition. Because I want to give you enough time. It's not like you're just coming and presenting and, it's called churning the work, just taking the burden off your shoulders. No. I want you to think about it and come up with solid ideas. Right? For this, I think you need more time. Friday. Yeah. Next Friday. Yeah. According to Navira, next Friday is fun. Everybody agrees? Yes. Navira is saying yes. 16 is it. The 16th January, I'm thinking, so far tentative date is 9th January, right? But if I have a problem in finding the judges, I may extend the date. Right? And the next date that I'm proposing is 16th of January. So all of you have written down your pitch plans and ideas. Did you find any similarity in your ideas, the ones who have written it down? Yes. So what are you planning to do about it? So what will happen if I find that 2 different groups are working on the same idea? How would you suggest to proceed?
Combine.
Huh? Combine. This means 8 people will be presenting the idea? There are 2 ways you can do it. Either you change your idea completely, one thing, or you modify the existing idea a little bit so that it looks different than the other idea. So this is the 2 things you can do. How many of you from this these tables and this one, you find their ideas are similar to other groups? Can you raise your hand? Only 2 people? One person from a group. One person from a group, raise your hand where you find that your ideas and other groups' ideas are same. Your group? So both you are at the same. What is your idea? What are you working upon?
Waste management.
Waste management, and what is yours?
Yeah, the same.
Waste management. How are you planning to do waste management? Manage it. Like what is your idea about managing it?
Our idea is carbon-free home dustbin, living dustbin, which is used for the organic waste in the household environment.
You also the same?
Yes. Waste management, but not like this. We are using a black soldier fly.
You're using black soldier fly, you're using microbial culture, and what are you planning?
The agricultural waste that we usually get from our...
The agricultural waste, how you are planning to dispose it of?
And this is just the idea, we will just...
Okay, so your idea is just agriculture based, but you don't know how to fix that issue.
We will look into it.
Our topic is also on agree with this waste management.
Agriculture waste management.
Then we want to change the
Production
idea.
of biodiesel.
Using a biodiesel
Production.
or using agricultural waste for biodiesel production? I think you guys are also doing exactly the same
And
thing.
also apply the AI on the synthesis of...
But see, when you use AI, it's a very vague term. I'm telling you, 99% of you guys don't know what AI is. You know how to make AI, the algorithm, how to design algorithm? You know it? Okay, explain.
Because I take a lot of courses.
What are the algorithm? How you design the algorithm for the waste management, for example?
I am applying the machine learning on the...
What is machine learning?
Synthesis of nanochemist.
Machine learning. So working with Dr. Riyaz, you are doing something AI. But okay, have you seen the rubrics for the pitch?
Yes.
In the rubrics I have mentioned, you have to have at least one slide about the prototype development. So you have to have one slide where you have a schematic of how are you going to design your prototype. right? So just keep that in mind. So when you're talking about AI and all those things, we have to explain step by step that how you're going to make the final prototype, right? So you should have all those things written down properly, and it should be easy to understand. Because if you are taking 10 minutes just to explain the idea behind it, you are exhausting the judges. It will go against you. They will not give you points for that. So where is the list, please? Can we have another page also circulated here? Hello? Can we have one of the pages circulated here to the boys? There are 2 pages in here, right? No more than 2 pages. So just give me one blank page. I need one blank page. There are 3 pages, right? Give here to the boys. So please write down your ideas here. I just want to know there is no duplicate. The ones who are not enrolled in the entrepreneurship program of the course, please, if you want, you can leave. The class is done for today, the bioinformatics class. You guys are done? Huh? So yeah, that's it. You already have to come, right? But you need to think about how to make it different. You already have to tell people at least. Actually, 4 people are talking about it.